This lesson is solving quadratic equations. So by the end of this lesson and the associated practice work, we want to be able to solve a quadratic equation of the form ax squared plus bx plus c equals 0 by factoring. And really, this is why we've been doing all of this work on factoring. This is one of the main things that we are going to use factoring for, is solving quadratic equations. But before we get into quadratic equations, let's take a step back and just refresh our memory on what it means to solve a linear equation. So here I have a linear equation, 3x minus 6 equals 0, and we know how to do this by now. We are going to use opposite operations to get x all by itself. So I'm going to add 6 to both sides to get 3x equals 6, and then I'm going to divide both sides by 3 to get x is equal to 2. So we have a single solution to our linear equation, just one value of x. And what does it mean that this value of x is a solution to our equation? Well, it means that if we take this value of x and we sub it back into our equation, so for instance, if we think of this as looking at the left side of the equation is 3x minus 6, and the right side of the equation is 0, if we sub 2 in for x, we'll get 3 times 2 minus 6, which is 6 minus 6, which is 0. So the left side is equal to the right side. And if the left side is equal to the right side, we would say that x equals 2 satisfies the equation, or it's the solution to the equation. And if it's a linear equation, there is, again, a single solution. There's only one value of x, which is going to have this property, that it makes the left side equal to the right side. So let's jump in on what we want to learn today. We'll start off with something really simple, a few linear equations that we want to solve. So our first one here, x minus 3 is equal to 0. We can do opposite operations here, like to get the x all by itself, we could add 3 here and add 3 here to get x is equal to 3. But something like this, you could probably just look at it and say, okay, I know I need to put a 3 in here because 3 minus 3 is going to be 0. And if we really wanted to, we could do the left side, right side check. You know, our left side is x minus 3, sub in our x value, and we get 0, and our right side is 0. But we can kind of see that this is true just by looking at this one. So let's look at the next one. X plus 5 is equal to 0. I think we could probably do this one just by looking at it as well. We could say, okay, what value of x has to go in there to cancel out with that positive 5 and give us 0? Most people would say, all right, x has to be negative 5. And we could, if we wanted to, you know, subtract 5 here and subtract 5 here. We're just going to end up with x equals negative 5 again. Our third one over here, 2x minus 4 equals 0. Let's go ahead and do the opposite operations here. So I'm going to try to get the x all by itself. I'm going to add 4 to both sides. Those negative 4 and positive 4 are going to cancel. So I'll get 2x is equal to 4. And then I'll divide both sides by 2. And I will get that x is equal to 2. And if we just do the substitution sort of mentally here, we can see that, okay, subbing 2 back in here for x, I'm going to get 2 times 2, which is 4. And then minus 4 is equal to 0. So these linear equations are pretty easy to solve here when we've got, you know, all of the x's and the numbers all on one side, and we just have 0 on the right-hand side. Now, let's look at a couple of equations here that are not linear equations, okay? We've got x minus 4 times x minus 2 is equal to 0. And we can think of solving this by solving this little part here separately from this little part here. When we look at the first part here, x minus 4 is equal to 0, I think it's not too much of a stretch to say that just sort of looking at what we did up above, our solution might be x equals 4, okay? And this kind of makes sense because if we check and see what happens when we sub x equals 4 into this entire equation, we are going to get 4 minus 4, 4 minus 2, 4 minus 4 is 0, 4 minus 2 is 2, 0 times 2 is 0, so our left side is equal to 0, and of course our right side is equal to 0. And when we look at the second bracket, again, if this was a linear equation, we would look at this and just say, okay, our solution here has to be x equals 2. And x equals 2, we can see has the same property as x equals 4 does with regards to this equation. If we look at our left side, and instead of subbing in x equals 4, we sub in x equals 2, we're going to have 2 minus 4 times 2 minus 2. Negative 2, 0. Negative 2 times 0 is 0. And so our right-hand side is still 0. We've got something that satisfies our equation. So in this equation here, we didn't just have one solution, we had two solutions. Both x equals 4 and x equals 2 are solutions to this equation. Two solutions. Okay. And these solutions are pretty easy to find when we have them written in brackets like this. I don't think it's, we can look at this one here and we can say, okay, x minus 3, x plus 2, these are multiplied together, this is equal to 0. We can sort of see that if we make either one of these brackets equal to 0, then the whole thing is going to equal 0 when we multiply them together. So it's like we have two little mini equations here. We have an equation x minus 3 is equal to 0. Our solution there is x equals to 3. And then we have a second little mini equation, x plus 2 is equal to 0, and our solution there, x equals negative 2. And both of these x values are going to be solutions to this equation. Again, we have two solutions to this equation, because if we sub either one of these in, it's going to make the whole thing equal to 0. So these two equations that we've just looked at are quadratic equations. Now, our linear equation, we just want to make a connection here. Our linear equation, if we have 2x minus 4 is equal to 0, and we look at our graph over here on the right of y equals 2x minus 4, we saw that when we were just working with this equation here that, well, we solved it by doing opposite operations. We did 2x, we added 4 to both sides, then we subtracted 2, and we got our solution, x equals 2. And if we look over here at our graph of y equals 2x minus 4, this point, x equals 2, is right here, okay? This is the x-intercept of the graph of this line over here. And this kind of makes sense to us because we can imagine taking like this equation here, y equals 2x minus 4. And remember how we found y-intercepts. We found x-intercepts. We found x-intercepts by setting y equal to 0. So if we set y equals to 0, we get 0 equals 2x minus 4, again, which is the equation that we just solved up here. Okay, so the solution to a linear equation where we have our x and our numbers on one side and the whole thing is equal to 0 is just the x-intercept of our line. Well, let's take a look at this equation, 0 equals x minus 3, x plus 2, that we just looked at. This is in fact a quadratic equation. Now, how can we show that this is a quadratic equation? We can do the FOIL thing that we've been working on. We can expand this out. I'm going to keep the 0 the same, but I'm going to do x times x to get x squared, x times 2 to get positive 2x, negative 3 times x to get negative 3x, and then negative 3 times 2 to get negative 6. And then I'm going to collect these like terms together. So this we recognize as a quadratic because we have an exponent of 2 here on the x. Okay, so this is a quadratic equation. Now, when we solved this, we saw that we had two solutions, x equals positive 3 and x equals negative 2. And these came from looking at what would make those two brackets equal to 0. Well, let's take a look at our graph over here of y equals x minus 3, x plus 2. Notice that, like we've learned already, this parabola here has two x-intercepts. What are our x-intercepts? They are x equals negative 2 and x equals positive 3. So the solutions to this equation are, again, the x-intercepts of the parabola. Okay. So we know that parabolas can have two x-intercepts, they can have one x-intercept, or they can have no x-intercepts. The same is also true of quadratic equations. A lot of the time they have two solutions, sometimes they only have one solution, other times it's possible to have one that has no solutions. Okay, let's put all this stuff together and talk about what you need to be able to do here, okay? We know that a quadratic equation looks like this. X squared minus 8x plus 12 equals 0. We know it's quadratic because of the x squared. To solve it, we're going to make use of this thing that we've been talking about, which I'm going to call the zero product property. The fact that if we know that two things, a and b, are multiplied together equal to 0, then either a is equal to 0 or b is equal to 0. And we're going to use this property along with our knowledge of factoring to solve quadratic equations. So let's start with that quadratic equation we just looked at. X squared minus 8x plus 12 equals 0. We want to write our equation in that form where we have something times something is equal to 0. And the way we're going to do that is we are going to factor that expression on the left-hand side. So if we are factoring this quadratic here, we are looking for, again, we're looking for two numbers. These two numbers have to multiply to 12. They have to add to negative 8. These two numbers are going to be negative 6 and negative 2. Negative 6 plus negative 2 is negative 8. Negative 6 times negative 2 is positive 12. Those signs are important. So we know that once we figured out those two numbers in factored form, this is just going to be x minus 6, x minus 2, and then we're going to keep the equal 0 in the exact same spot. We've just factored the left-hand side. Now that this is in factored form, we know how to solve it. We take each one of these factors here, and we think of it as its own little mini equation that we can solve. Our solution here is going to be x equals 6. Our solution here, x minus 2 is equal to 0, is going to be x equals positive 2. So we set each of these factors equal to 0, and then we solve these little linear equations for x. And step 4 would be we could check, so we could do a left side, right side check. We'll do this with one of them. Let's say our left side is x squared minus 8x plus 12, and we sub in x equals 2. That's 2 squared minus 8 times 2 plus 12. That's going to be 4 minus 16 plus 12. That's 0. And our right side, well, that was 0 to begin with. So our left side is equal to our right side. So x equals 2 is definitely a solution. And we'd get the same thing if we subbed in x equals 6. So let's do one more as an example, and you can start work on the practice questions. Our quadratic equation here is x squared minus x minus 20 equals 0. And we want to do the same things. Our first step is going to be we want to factor this. So we are looking for two numbers that are going to multiply to negative 20, and they're going to add to negative 1. These two numbers are going to be 4 and 5. 4 and 5 definitely multiply to 20. One of them has to be negative, so we can get that negative 20. Which one? Well, let's see. If I make the 5 negative and the 4 positive, 4 minus 5 gives us that negative 1. So we know that this in factored form is going to be x plus 4, x minus 5 equals 0. So we factored it. We'll set each of these factors equal to 0. And let's solve for x. X equals negative 4, x equals positive 5. And these are our two solutions. And let's check one of them here. Let's check x equals negative 4. So our left side is going to be negative 4 squared minus negative 4 minus 20. And of course our right side is still 0. Negative 4 squared is negative 4 times negative 4. The two negatives give us a positive 16. Plus 4 minus 20. 16 plus 4 is 20. 20 minus 20 is 0. So left side equals right side. This is the solution.